Ladies and gentlemen, thank you very much for giving me voice. Today I will talk about enhancing and upgrading biogas and biomethane production in our aerobic digestion, a comprehensive review. The work is written under cooperation of Australia and South Africa and Nigeria universities under leadership of Professor Rizwanov Khattar. The work is published in Frontiers of Energy Research. The anaerobic digestion is a special kind of microbial decomposition which, under hydrolysis, provides to acidogenesis, and then this anaerobic part can stimulate it if unstopped, and metalobacteria occurs in these, and methanogenesis occurs further. There is final product methane. Methane can be used as energy carrier and for synthesis and, for example, replacing of natural gas. Other case is some unreliable biogas compost and other undesirable components such as carbon dioxide, oxygen, hydrogen sulfide, water vapor, ammonia, dioxins, nitrogen, hydrocarbons, and carbon monoxide, which can be impurities, but still, as we see yesterday, dioxide can be done, maybe reproduced into, well, for example, for wheat straw or for sugarcane straw under special condition into nano silica, but here are considered usually a big trouble because blocks and marks corrosiveness of pipes. Because of contain oxygen, and then it's unlikely. So these are what we don't want, siloxanes. And this contains an introduction, and this substrate and will contain carbohydrates, protein, and lipids, and commonly are hydrolytic enzymes, which will breaks into amino acid and simple sugars, and lipids pathway caused by enzymes also such a long-chain acids, and then aerobic digestion leads to first the acetic acid, which is not fuel because butyric acid also, which can be used in voltaic acid, can be used in fatty acid used in other techniques, and hydrogen other for biofuel, but we are interested in finding a way which converts acetic and hydrogen carbon monoxide all into methane and some carbon dioxide. And in this step also is hydrogen sulfide because it is the parallel process to hydrogen production. So it is converted into other compounds on this side. So it exists as hydrogen sulfide. And here this process is complex multi-process step, and nutrients are important, for example, iron and ammonium salt for being present in process of transition to fuels, and is very important to immune this process as well as biochar some spherical as marble, which also can help. Here we have substrate for biogas or methane is wastewater, agricultural waste, energy crop residues, and municipal biowaste, household waste, industrial waste. These are aquatic biomass. Aquatic biomass means microalgae and algae that we talked yesterday, and is 2 days ago, and is very important because it can be material for polyalcohol, xylase, and polymers, and also can be produced to become methane source and extraction. So many by this process can be made. Therefore, more evaluation to select important technologies limited. In this research, we have a review of enhancing biogas method. The composition of biogas from biowaste is 45 to 75% of methane, if not upgrade. But we need in the batch that is 85, that is suitable. So the batch process needs to be 85 to be considered then into methane production. The upgrading is usually by adding some hydrogen or by giving, as yesterday, some polymers, some feed initially. It will upgrade and give in 80%. In such case, if we get with less hydrogen sulfide, less siloxanes, and ammonia. Here we note the typical biogas composition of hydrogen, which contains 2%. So it's not very precise. The methane can be used in petrol, heating, and natural gas. However, for natural gas needs to be firstly remove hydrogen sulfide, and this is final stage after reaching composition and separation is added for safety. There also is uses of pretreatment. So pretreatment has to be prepared of substrates to be higher production, and lignocellulose can be used to remove hemicellulose or cellulose, or remove lignin basically, which blocks bacterial growth, so in rubber and deodorant. However, without cotton is also because crystallinity. So in some cases, some is going to zero lignin, but some little part is useful still. Can be useful. Enhancement of anaerobic digestion, so upgrading, is bioaugmentation, use of inoculum or seeding bacteria properly pretreated, use of carbon-based conductive material, not only carbon-based, but mostly, but silicon also can be, because scale some works also can be used at this point. Biostimulation, use as macro and micro nutrients, use of improved reactor configuration and operating conditions, use of co-digestion, use of pretreatment. Physical techniques include mechanical preparation, milling, grinding, leasing, centrifuge, high pressure homogenizing, thermal and microwave irradiation. Some also photocatalytic or mechanocathalical is chemically physical, which can be also by mechanical pretreatment. And this using thermal, so the composition also some hydrothermal, so using hot water or supercritical even, but requiring much equipment, sonication, and chemical method. This oxidation, acid, alkali, and other pretreatment, but also using some ionic liquids or eutrophic mixture, eutectic mixture, which helps to musen. As biological technique, we have enzyme and biological preferential pretreatment, which is slow but low energy required. And this is thermal pretreatment. Thermal pretreatment using are costly mostly because it's much high, but in some case can be, in case of wood, can be more efficient. However, hope is microwave radiation, but still it will have much losses on the free product, and this is the major product. Similarly to sonication, is using sound effects, and acid pretreatment is can be useful, but with acid, but is trouble with the corrosiveness of material. So high saturated are very well breaking the substrate, the compost substrate, but producing also some hydrom HMF, so hemifurfular, and this is the trouble. And this is oxidation pretreatment by hydrogen oxide or oxalate, which breaks, but is the most costly than acidic, which is trouble. And ozonolysis is very costly material still, but not very, very useful. Biologic technique, fine job and useful. There are mixture of chemical and chemosonification, which are mostly upgrading, but requires positive hard in design to make it efficiently, and even is energy requirements, costs, and efficiency. So these are parameters of using. Therefore, biological possess more techno-economical merits across the criteria compared to the pretreatment. The benefits of biological pretreatment are associated with the capacity to prevent the generation of byproducts that are inhibitory or toxic to methogens, low operation cost and low energy requirements, but leads to improved efficiency, which is focused maybe of rate of hydrolysis enhancement in order to enhance recommended parameters as pH, incubation, temperature, aeration, because incubation is helpful. So this is all. And the use of additives, biological are uses of cold digestion, so using many substrates and many bacterial culture in many stages, and biostimulation by using proper adsorbent ion exchange, nanomaterials, and bioaugmentation. So this is all. And yes, and this is the upgraded purification, the absorption, and we have here the self-reactive pores, open pores, open bioreactors, and photobioreactors, and organic physical scrubbing, a scrubbing for purification membrane mostly is efficient but requiring much materials. Now are efficient much works to make it more suitable, and the most is pressure swing absorption as for some mostly used, but in the case of metal is much less requiring, and water scrubbing as using for metal. Metal is much more known, so we can cheaper by stripper and absorbing and upgrading biogas produce. So this is the what I wanted to say today. Thank you very much for listening to me.